All right, so next one. Any questions on that one? All right, in 2016, roughly 13 of every 100 people in the United States were African American. A marketing company wants to select a group of 250 people that accurately reflects the racial makeup of the country. How many African Americans should be included? So the first thing we do is start with the ratio that they gave us, which would be 13 out of 100. And then I want to know that if I chose a group of 250 people that accurately reflects this, that would be my total amount of people. And the question is, how many of them would there need to be African American in order to represent basically 13%? Because this is 13%. So on the top, we have the number of African American. On the bottom, we have the total amount of people. So when I say be consistent, I mean that both items on top should represent the African American number. Both items on the bottom should represent the total. If you have it set up like that, then when you cross multiply, you should have it set up correctly. So if we cross multiply this, you would have 13 times 250, which would give you 3,250. Cross multiply the other side. So then when you divide that by 100, you get 32 and a half. Can you have a half a person? So here's one of the things where we talk about answers that make sense in terms of the question. And so how many African Americans should be included? We would round down because you can't have just half a person. So your final answer would be 32. If I did 33, it would be too much. So it's better to be just a little below than a little above. Try number C on your own, see if you can set it up right. Okay, when you're talking about ratios or thinking about proportions, one of the things is you want to pick out a proportion that they gave you, and that kind of helps you set up where you're at. So first of all, if they catch a sample of 35 fish and tag them, that 35 fish was in comparison to the entire population, right? So they caught 35 fish, and that was in relation to the entire pond. So then what they're saying is later on, they caught 80 fish and only 5 of them were tagged. So using that proportion to where the number tagged is on top and the total amount that they're looking at is on the bottom. So 35 fish were tagged out of the total population. 5 fish that they caught were tagged out of the 80 that they caught. So this is how you would set up the proportion. And I am going to say this just kind of off to the side. Some people flip them, so that's what I meant when I said be consistent. So you can write this as x over 35 is equal to 80 over 5. You're going to get the same answer. So as long as what's tagged is both in the bottom or both on the top, and the total is both on the bottom or both on the top, you're going to get the same answer. So both of these are the same proportions. They can be flipped. If you're writing them backwards, you don't have to change them. You're going to get the same answer. So then you would have 35 times 80. That's not 35. So that'd be 2,800. And then 5x. So if we divide that by 5, we are estimating that there's about 560 fish total in the pond. And these are all approximations. Anytime you use these proportions to it's an estimate. So a lot of the times they use these to estimate like bad product. So like on an assembly line, 5 out of every 600 products come out defective. So we could estimate what our loss is in our profit if we know just about how many are going to come off the product line that are going to be defective and not be able to be sold. So it's a way to estimate things to kind of give us something to expect later. We could estimate the decrease in wildlife, and that's how they kind of predict when populations are going to grow or decrease, which is kind of what they're talking about in the next one. So the staff biologist at a wildlife preserve tagged 74 protected woodpeckers shortly after hatching in the season. In midsummer, 30 of the birds were caught and 16 were tagged. So again, 16 were tagged out of the 30 that they caught. 74 were tagged to beginning out of the entire population. So this one sets up just like this one. They're just talking about a different type of species. So 16x and 30 times 74. Which would mean that, and again, we're going to round down because you can't have 0.75 of a woodpecker. So we'll say about 138 would be our number. Questions on any of those? Okay, the last thing that we'll talk about very quickly is direct variation. Direct variation is pretty simple because it's, if you remember talking about direct variation in algebra, it basically means that it's y equals mx, if I put it in terms of something that you remember. So you remember y equals mx plus b. Please tell me you do. Yeah. Thank you. Even if you don't, tell me you do. It'll make me feel better. What happens with direct variation is you have something that is directly related to what it is that you're talking about. So there is no plus b. It's really going to look like this if I kind of relate it to something that you already know. We write the equation a little bit differently because we use k. We use y equals kx, but it's the same type of deal. It means that it varies directly with each other. So there is no other outside source that affects it. So whatever k is dependent upon x and kind of vice versa. So direct variation, a quantity y is said to vary directly with x if some non-zero, and this is math talk, non-zero constant, which they represent as k, right, is paired in an equation that looks like this. And it'll make more sense once we get there. K is what they use to represent the constant of proportionality. It means k is the value that you're getting charged every day, or k is the value that you pay every day. It's something that happens consistently, I guess is the word that I'm looking for. So in terms of just trying to like help you understand that, if you earn $95 per day, 95 is your K value. It's that constant of proportionality. It's something that doesn't change. You are constantly getting paid $95 per day, which means that when we write the equation for this, this is what it looks like. Then what happens is they give you some value of x. So in this case, x stands for the numbers of days that we work, and she gets paid $95 per day. So if I want to know how much she, find the total of pay if you work 6 days and if you work 15, then you're just plugging those numbers in here because this is based off per day. So 95 times 6 would be your answer for 6 days, and 95 times 15 would be your answer for 15 days. So 570 and 1425. So varying directly means that there's one item that we're using and it's the same item per whatever it is that we're talking about. And there is no outside plus B, if you will, that kind of affects what the outcome is. So on B, a 6-month-old lab puppy gets 4.5 cups of food per day. So that means that our equation that we're looking at is 4.5x. They're getting 4.5 cups per day. Write a variation equation that describes how many cups of food she eats in terms of days. That's what I just wrote. And then use it to find how much she eats in 6 days and in 2 weeks. The thing you have to be careful about on these is that the first one, you wrote the equation in terms of days. So when you're talking about 2 weeks, what number are you going to plug in? 14. So the only thing you have to be careful about in writing these is that when you go to plug in for X, you're making sure you're plugging in what you wrote the equation for. So if I wrote it in days, then I need to make sure I'm plugging in the days and not weeks, years, months, something like that. So then 6 times 4.5 would give you 27 cups of food for 6 days. And that would be 63 cups of food for 14 days. How are we doing on that? Good? Great. Flip page. Last one with the direct variation. When utility cables are strung above ground, the weight is an important consideration. The weight of a certain type of cable varies directly with this link. If 20 feet of cable weighs 4 pounds, find K and determine the weight of 75 feet of cable. So this is kind of what this looks like. You've got 20 feet is 4 pounds, right? Is that what it said? So if I set this up in an equation, I know that 4 feet is going to be equal to something that varies directly if I were to plug in 20 feet of cable. So you're using the same equation, but what they've done is kind of given you an X and Y point in terms of your equation. They've given you a combination of information and you plug it in where it goes. So 4 is your total, 20 is what you're looking at, and you're trying to solve then for what does that direct variation have to be in order for this to be equal. So if I take 4 divided by 20, right, to solve for this, you're going to get 0.2, and you just figured that in pounds per feet. Pounds per feet. So it's 0.2 pounds per foot. So then what's the other question? Find K and determine the weight of 75 feet. So since I found K, now what you're doing is taking that, plugging that in for your direct variation and multiplying it by the 75 to see how much that is going to weigh, which in this case would be 15 pounds. So this is going to be one, I know you have a question like this on your homework. So keep in mind that when they give you a set of information that kind of looks like it would be a proportion that's together, then you're taking that information and plugging it in for X and Y and solving for your K. And then typically they're going to ask you up a follow-up question to then use that K and plug something else in. Questions on that one? Okay, the only other thing that we talk about is varying inversely, which is still kind of using the same equation that we just talked about. So varying inversely, if some non-zero constant K, it is said to vary inversely if some non-zero constant of K, which is kind of what we're figuring, such that we can use the equation y equals K divided by X. So the time it takes, is that what I wrote? Okay, the time it takes to drive a certain distance varies inversely with speed, and the constant of proportionality is the distance. A family has a vacation cabin that is 378 miles from their residence. Write a variation equation describing driving time in terms of speed, then use it to find the time it takes to drive that distance if they take the freeway and average 60 miles per hour, and if they take the scenic route and average 35 miles per hour. So the idea here, and I'm going to write it out so you can kind of see what everything stands for, is that in this case, y is equaling the time, right? X is your average speed. And K here is the 378 miles that they have to travel. So using that equation, what we're saying is the amount of time that it takes varies inversely to 378 divided by whatever their average speed is. Okay, so if their average speed is 60 miles per hour, we're substituting that in. And that would give us about 6.3 hours. And then what was the other one? 35. So then if you take 378 divided by 35, that would give you 10.8 hours. Okay, so one of the things that's helpful in these is to read what they tell you or how it's set up. So if you read, somebody I can tell already is going to ask me, how did I get this? The time it takes to drive a certain distance varies inversely with the speed. So if I take the time, which is your y, right? It varies inversely with the speed and the constant of proportionality. So you take miles per hour, and that's how we come up with our equation. So I don't know if you remember that distance equals miles per hour, or distance equals rate over time. Or time, rate, yeah. Rate equals distance over time. I wrote that backwards. We used to use those equations a lot in algebra, so I don't know if you remember those equations or don't remember those equations, but that's kind of what leads into this ratio over here. So distance or rate. Questions over that one? Okay, in construction, the strength of a support beam varies inversely with the cube of its lengths. So basically that means that if I were to kind of write the generic equation, the strength, which would be y, varies inversely with the cube of its length. So how do I cube something? Looks like this. So if I start off with that equation, it's still k. We're still just writing exactly what it said. If a 12-foot beam can support 1,800 pounds, how many pounds can a 15 beam support? So it's kind of like the one up here on C. So if 1,800 pounds is supported by a 12-foot beam, then you plug in what you know and you solve for what you don't. And then you can use whatever you get for K in an equation with 15. So if 1,800 pounds can support a 12-foot beam, how do I get rid of a denominator? Times it. So if I take 1,800 times 12 to the third, a big large number, 3,110,400, right? So then we're using this as our K value. So if I do y then equals this number, so that's where K goes, divided by 15 to the third beam, and how much would it be able to support? Uh, 921.6. Questions on that one? I don't think, just to throw it out there, that I put any of the direct variation ones on here. I think they're all proportions. But at least we talked about it. Questions before I pass this out?